Hello, my amazing math students. This is Mrs. A, and I love math. And today we're doing lesson 89 in your Saxon Orange book, and we're doing value problems, which coin problems. We've done coin problems before, and coin problems are value problems. Now we're doing some other types of value problems. Airline fares, for instance, airline fares for flights. Now, these are very nice airline fares. They must only hop between very short cities or something because they are quite the deal, aren't they? But anyway, $30 for a first class seat and $25 for a tourist class seat. 52 passengers paid $1,360. How would we go about finding out how many of the passengers were first class and how many of the passengers were tourist class? Okay, it's really not as hard as it looks. So we're going to use F for first class for the word first, and we're going to use T for tourist class. Okay, so let's keep it as simple as we can, right? We know that there are 52 passengers altogether. So don't I know that the number that purchased a first class ticket and the number that purchased a tourist class ticket add up to 52? There's one equation. Now, don't I need two equations? Because I have two unknowns, I must have two equations, and there's one right there. Then we have to do the equation, which is about the amount of money. So first class, the number of people each paid $30. So the amount of money that came from first class people would be 30 F. The tourist class people paid $25 for their seat. So the amount of money made from tourist class would be 25 T. And then I'm going to add these two amounts together, and I'm going to get 1360, 1,360. Two equations, two unknowns. Not too hard, right? So what we can do is we can take this one. Let's use substitution. Let's take this one and solve it for F. So let's say F equals 52 take away T, minus T minus T. 52 take away T. So now I'm going to go through in this equation, and instead of F, I'm going to put 52 minus T. So since my board's a little crowded already, I'm just going to take this 30F off, and instead of the F, which was right there, I'm going to replace the F with 52 minus T. So now I have one equation, but I only have one unknown. The unknown is T. So let's distribute. 30 times 52. Okay, well, I can tack on the zeros. So 3 times 2 is 6. 3 times 5 is 15. Tack on the 0. Minus 30 times T plus 25T equals 1,360. Okay, so now we have a minus 30T and a plus 25T. So isn't that, now I'm going to erase this one right now. Here, I'm going to put it right here so we don't lose it. Because that one turns into that one. I'm going to give myself a little bit more working room here. But we really don't need too much because we're going to add these two together because those are like terms. And negative 30T plus 25T is negative 5T. Now, I'm going to go ahead and take this one right here and subtract it. So minus 1,560 on this side, minus 1,560 on this side. So that goes to 0. This is gone because I just added those together. And 1360 minus 1560 is negative 200. Well, I don't want negatives in my answer, but I want t by itself, don't I? So I'm going to divide by -5 and divide by -5. And I'm going to wind up getting t equals, and that's the tourist class, then 200 divided by 5. Well, I know that 20 divided by 5 is 4. So 40, and then negative divided by negative is positive 40. So out of the 52 passengers, 40 were tourists. So if 40 were tourists, then wouldn't 12 be first class? And that's really all there is to it. Aren't those fun? 2 equations, 2 unknowns. Okay, so on this next example, I'm going to go ahead and read the problem to you because it's quite long, and I have to have some room on my board to work the problem. It says, Watoxa's dress shop sold less expensive dresses for $20 each and more expensive ones for $45 each. The shop took in $1,375 and sold 20 more of the less expensive dresses than the more expensive dresses. How many of each kind did they sell? Okay, so here we have our board, and it says less expensive dresses were $20, more expensive dresses were $45. They took in $1,375 and sold 20 more less expensive than expensive. Okay, so how do we represent this material? So we're just going to call less an L and M for more expensive. Make your variable something that makes sense to you. All right, so I know that the total number of dresses, we have a little bit more difficult here. So we say they sold 20 more less expensive. So we can say less expensive is 20 more than more expensive. Okay, so this equation is one of our equations. And we also know that the amount of money that they spent on both types of dresses was $1,375. So let's put that in equation. If we're talking about the less expensive dresses, this is the number of less expensive dresses times 20 for each one. So 20 times L is the amount of money that they spent or took in as the store on less expensive dresses. And then the $45 dresses, they sold M of those. And altogether, that amount's going to equal $1,375. Do we have 2 equations with 2 unknowns? We have enough, don't we? So this one is already set up for substitution. So why change it? It's already ready. So we're going to slide this L right here in here. So 20L, I'm going to make it a little bigger, 20L, and the L is going to be replaced by M plus 20. Okay, so now we have to do some distribution. 20 times M is 20M plus 400 plus 45M equals 1,375. So we have 2 M's, 2 like terms here. And we have this 400. Let's get rid of the 400 from both sides. So 20M plus 45M is 65M is equal to, now let's subtract. So 5 minus 0 is 5, 7 minus 0 is 7, 13 minus 4, because that's not enough, so we have to come over here and borrow. 13 minus 4 is 9. So our answer is going to be 975 divided by 65 is the number of more expensive dresses that are sold. Okay, so I'm going to get a little board to do that. Okay, so here we have 975 divided by 65. 65 will go into 97 one time. 1 times 65 is 65. We subtract 2, 3, bring down our 5, and 65 goes into 325. Let's say 5 times. 5 times 5, 25. 5 times 6 is 30, plus 2 is 32. It comes out exactly, which is nice. So 15 is the answer, and 15 is the more expensive dresses, okay, because that's the M there. So we're going to say M is 15. So we're going to come here, let's write it down, M equals 15. And then right here, to find the L, I'm going to put 15 right here for the M, and the number of less expensive dresses that were purchased were 35. So L equals 35 dresses. And aren't there 20 more of those than those? And if we take the 15 times the 45 and the 35 times the 20, we should get, again, the 1,375. And it works. So here's my work, just in case you can't see it very well as I'm working it. Those are your examples. Now we're going to do some practice problems. Okay, so let me read the first practice problem for you. Tickets for good seats cost $8. And tickets for the other seats, we'll call those the cheap seats. Because I'm always looking for good variables, and O does not make a good variable because it looks too much like a 0. So we're not going to use O for other seats. We're going to use C for cheap seats. Okay, you could use B for bad seats if you want to. If they're good seats, and then the others must be bad seats. So we're going to use, in mine, we're going to use C for cheap seats. Cost $3. If 18 tickets were sold for a total of $119, how many tickets for good seats were sold? All right, so that is your practice problem, and I've set it up for you. So here we have good seats, $8, cheap seats, $3, 18 tickets sold for $119. And now you need to pause your video and go find out how many of each type of seat were sold. Go ahead. Pause your video. I hope you did so. All right, so here we go. We have two unknowns, so we need two equations. So we're going to say, okay, the value we have. So we're going to say $8 per good seat. So good seats times $8 gives you the amount of money that was made from good tickets, plus cheap seats times $3 will give you the total amount of money that you made, $119. And the number of good seats plus the number of cheap seats will equal the 18 tickets sold. Two equations, two unknowns. So now we can easily substitute. We could use our elimination if we wanted to multiply this whole thing by 3. But when you already have these singled out, it's usually easiest to use the substitution. So let's solve for G. G is equal to, subtract C from both sides, 18 minus C is equal to G. So now I'm going to rewrite this equation with G substituted in. So here's my G, and I'm going to say 8G, and instead of the G, we're going to put 18 minus C plus 3C is equal to 119. So 8 times 18, okay, 8 times 20 is 160. And 8 times 2 is 16. So 160 minus 16 is 144. Okay, so 144 minus 8C plus 3C equals 119. Okay, so now we need to put these, I'm going to take this one and take it over here, because I already have both c's on this side. So negative 8c plus 3c is negative 5c equals 119 minus 144. The easiest thing to do is to go ahead and subtract this minus this and make it a minus sign. So let's do that. 14 take away 9 is 5. And that's going to be a 13 minus 11 is 2. I'll check this, but I think I'm right. So now C is going to be negative 25 divided by negative 5 is 5. So 5 cheap tickets. Okay, and then the number of good tickets would be, since it's 18 minus 5, so 18 minus 5 would be 13 good tickets. Okay, everybody wanted the good tickets. So now let's see if it makes sense. 13 times 8 is, 8 times 3 is 24. Carry the 2, 10. 13 times 5 is 15. And when I add those up, don't I get 119? And I do. Did you get it right? Did you pause your video and do it by yourself? I hope so. Here's our last practice problem. At a basketball game, adult tickets sold for $5 and children's tickets sold for $2. If 175 tickets were sold for a total of $686, how many of each type were sold? Okay, so now we're going to figure this out. We know that the amount of adult tickets sold and the amount of children tickets sold altogether must equal 175. Did you pause your video? Don't let me do this for you. You need to go practice first. A plus C is 175. And then the amount taken in for the tickets was 686. So 686 would be from A, the number of adult tickets times $5 each, and then $2 for each child ticket, so 2C. Now, we're going to go ahead and use our substitution. So let's solve for A. Since A's in front, it makes it easy. Minus C minus C. Minus C minus C. So A is 175 minus C. This one goes out. So now that I have A equals 175 minus C, then I'm going to substitute that A in here. So 5 times A, but instead of the A, I'm going to put a parenthesis and put 175 minus C. Right there. And then plus 2C equals 686. All right, so 5 times 175. Those are big numbers, but 5 times 5 is 25. Carry the 2. 7 times 5 is 35, 36, 37. Carry the 3. 5 times 1 is 5, plus 3 is 8. Minus 5C plus 2C equals 686. So we're going to subtract the 875 and subtract the 875, which will leave us a negative number. But then on this side, we get a negative 3C. Oops. 3C, negative 3C. And then on this side, I'm going to subtract this way, but make it negative. Okay, so 5 minus 6 doesn't work. So 15 minus 6 is 9. And I had to borrow from that one, so that is 16 minus 8 is 8. And 7 minus 6 is 1. So now I have negative 189, and that is divisible by 3. Remember our divisibility rules. If I add the digits up, 1 plus 8 is 9, plus 9 is 18. And that is a multiple of 3, then so is the whole number. We just add the digits together. So this is divisible by 3. Negative divided by a negative is a positive. So C, let's see, C is going to be equal to, C is $2, but let's see how many. 18 divided by 3 is 63. 63 children's tickets. So altogether they had 175 tickets altogether. See if I can get that light bulb out of there. 175 altogether. So 175 minus 63 is going to be 5 minus 3 is 2. 17 minus 6 is 11. So 112 adult tickets. Okay, so how can we check that? First of all, we add these two together. We just subtracted, so we know that these two together equal 175, and they do. So now we need to check, do we get 686 when we multiply them? So let's throw them in there. Let's check it. So 5 times 112 plus 2 times 63. Let's see if we get 686. It's always smart to check our work. Okay, so 5 times 2 is 10. Carry the 1. Okay, right there. 5 times 1 is 5 plus 1 is 6. 5 times 1 is 5. Plus, then we add these together, 126. I add these two together. 0 plus 6 is 6. 2 plus 6 is 8. 1 plus 5 is 6, and it works. So, you have finished lesson 89, and we're going on to lesson 90 now. This is Mrs. A, and may God bless your day.